On 4.5, we will work with exponential growth. The formula for exponential growth is given by y equals c e to the power of kt, where c is the initial value, y is the ending value, k is the constant of proportionality, and t is the time, of course. So let's go ahead and look at the first problem. But before we look at the first problem, I want to grab your attention and on this, final answers must be accurate to 3 decimal places. Do not round your answer before it's final. So do not round anything till the last minute. Oliver Sutton is driving along a straight level highway at 64 kilometers per hour when his car runs out of gas. As he slows down, his speed decreases exponentially with the number of seconds since he ran out of gas, dropping to 48 kilometers per hour after 10 seconds. Well, we have a lot of information here. The first information that we have, or that I can highlight here, is the 64. This 64 seems to represent my C. That's C. Now, I have 10 seconds here. This represents my time. And the 48 kilometers is the time, the ending value, meaning this represents my y. The first question says, write the particular equation expressing speed in terms of time. So for A, I will say y is equal to c e to the power of kt. But here we have the value of y, which is 48, is equal to c here is 64, e to the power of k, we don't know what k is, but we know that the time here is 10. From here I will solve. To solve this, since it's a calculator portion, you can literally put this one y1, y2, but let's go ahead and solve it by hand because that makes more sense when we solve by hand. So I will divide both sides by 64 to get 48 over 64 is equal to e to the power of k times 10. From here to the opposite operation of e is natural log, I'll apply the natural log to both sides to get k, or 10k, is equal to natural log of 48 over 64. So to get the exact value of k, I will say k is equal to the natural log of 48 over 64 that you will divide by 10. Let's go ahead and plug this in the calculator. Once you plug it into your calculator, you should get an estimated answer of negative 0.02876 or 7.02, let's say 88. So on your paper, you will have k is approximately equal to negative 0.0288. So for A again, remember we're still on A. So the value for A, I will say y is equal to 64 e to the power of negative 0.0288 times t. Let's go ahead and solve for B. Predict Oliver's speed after 25 seconds. In other words, t is now 25. So to get t is now 25, all I need to do is say y is equal to 64 e to the power of negative 0.0288 times 25. So on my calculator, I'll go ahead and plug in as follow. I will say 64 e to the power of, I'll go back and select this, press enter, and I multiply that by 25. Note that I'm not using the rounded value, so I press enter, and it says is 31.177. Now, sometimes you will get the same answer even if you round it, but it's not always guaranteed. So I get y is equal to 31.177. The unit here is kilometers per hour. Let's do the last portion. The last portion is C. I would say for C, I want what time would Oliver's speed be 10 kilometers. So I would say 10 is equal to 64 e to the power of negative 0.0288 t. So to solve this one, I will divide by 64, or you will do your math here, and your final answer will be, after dividing by 64, you have negative 0.0288 t is equal to the natural log of 10 over 64. Now from here, you will divide by this value. So on your calculator, this is how you will plug it in. After putting the natural log of 10 over 67, I'll go all the way back. Before I go all the way back, I'll press divide by, and I'll go select back the same value that I keep using instead of the rounded value. And once you press enter, you get 64.526. So as your answer, it will be approximately equal to 64.526 seconds. Let's look at the next one. For problem number 2, it says the pressure of the air in the Earth's atmosphere decreases exponentially with the altitude above the Earth. The pressure at the Earth's surface sea level is about 14.7 pounds. Now this 14.7 pounds is the actual one, so it's giving me C. And the pressure at 2,000 feet is approximately 13.5. At 2,000 feet, that means it's my Y, the final one. Write the particular equation expressing the pressure in terms of altitude. So for A, I will start by saying, well, 13.5 is equal to 14.7 e to the power of k times here 2,000 feet. So I'll be 2,000 here. 2,000 is like our time here. So from here, you will once again solve it. And once you solve it just like we did on the previous one, you will get k is approximately equal to negative 4.258 times 10 to the power of negative 5. With this, you'll be able to write therefore for A as y is equal to 14.7 e to the power of negative 4.258 times 10 to the power of negative 5 A. So this is my equation. Let's go ahead and look at B. For B now, for B it says predict the pressure. Well, let's do BI. For BI, the altitude is 7,500. So for this, if the altitude is 7,500, all you got to do is put this on the y equal and go get 7,500. So for 7,500, you should get 0.681 psi. Note that I'm not doing it on my calculator, but I expect you to do it because this is how you learn. For the second one, you should get 4.276 psi. I'll jump to C now. For C, it says human blood at body temperature will boil if the pressure is below 0.9. So this is where we're trying to get. At what altitude will your blood start to boil? So I will start by saying 0.9 is equal to 14.7 e to the power of negative 4.25 times 10 to the power of negative 5. And here I still got A. My job is to solve for A. I will divide first to get, once I divide, I will apply the natural log to get negative 4.258. I'm missing an 8 here. 0.258 times 10 to the power of negative 5A is equal to the natural log of 0.9 over the 14.7. Using your calculator, you will find this natural log and you will divide by all this value to get A is approximately equal to 65,600.7491 feet. Guys, make sure you're getting the same answer on your calculator. Let's go ahead and do the last problem. The last problem says an isotope of sodium has a half-life of 15 hours. In other words, after 15 hours, whatever the amount you started with is halfway gone. How many hours will it take for 40% of given amount to remain? So let's start by interpreting the half-life. I would say half-life is equal to e to the power of 15k. In other words, regardless of what you're starting with, half-life is e to the power of 15k. Let's solve for k. I will find the natural log on both sides to get 15k is equal to the natural log of 1/2. So k is equal to the natural log of 1/2 over 15, which is approximately equal to negative 0.0462. I believe you can handle this on your calculator. That's the value of k. But again, I don't really need to box it because that's just a side operation. So the general formula for this will be y equals something with c. But since I'm not given c, I don't need to write the equation. But I do know that I want 40% remaining. If 40% is remaining, it means that I have 0.4 left of that substance. With 0.4 left of the substance, I want it to still be equal to e to the negative 0.0462 to the power times t. So here I'm solving for t. I will apply the natural log again to get negative 0.0462t is equal to the natural log of 0.4. And I'll divide by this value to get t is approximately equal to 19.829 hours. Once again, make sure you're familiar with how to use your calculator dealing with natural log and exponential. The rest will be your worksheets or your class assignment.